Hello, my name's Nigel Woden. I'd like to welcome you to episode 20 of the Wi-Fi for Beginners podcast. This is a series of podcasts discussing the fundamentals of wireless LAN networking. In each episode, we'll take a look at a different aspect of Wi-Fi to build your understanding and knowledge of wireless LAN networks. Each episode is accompanied by a set of slides describing the topics covered in that episode. Although you don't need to review these slides while you're listening to the podcast, they can be useful for reviewing the material we discuss and might provide some useful visual aids to more fully understand some of the concepts and equipment that are described in the podcast. All recordings and supporting materials for the podcast can be found at wififorbeginners.com. So in episode 20, we're going to continue our discussion of wireless controller management. We're actually on module 6 of the podcast. The podcast itself is broken down into a number of major modules which cover fairly major topics within wireless LAN networking, and we're on module number 6 which covers wireless control and management, and we started the discussion of this particular topic back in episode 19. So if you're listening to the podcast for the first time, you might want to jump back to episode 19 to catch the start of this particular module. And if you haven't heard any of the other previous modules, it might be worth going back to episode 1 and working your way through to this particular module, because we do build on quite a few concepts that we've discussed in previous episodes. So we'll actually kick off this particular episode with a very quick review of the slides that we covered in the last episode. If you're following along with the slide deck, we actually got up to slide number 15. If you haven't got a copy of the slides, you can go along to the website, wififorbeginners.com, and download a copy of the slide deck. So just to review, we actually started on slide number 6 in the slide deck, where we started looking at the need for controller management in a wireless LAN network. And we discussed the way that once we get beyond a handful of individual wireless access points within a network, it becomes very difficult to ensure we have consistent configurations across all access points. Becomes very time consuming and is prone to errors, and so some sort of centralized management technique is very useful to mitigate this. And in addition to the management of individual access point configurations, we also start to have to worry about the control, the coordination of all access points, so they operate together as a complete wireless LAN system. And things like channel assignments and AP transmit power management becomes very important. And this is why we have a requirement for a device such as a centralized wireless LAN controller, so that it can have this global view of a wireless LAN infrastructure and make the control decisions which are required. We also updated our baseline reference model that we've been using since the start of the podcast series. We looked at the traditional core distribution and edge network. We've got our layer 2 edge switches with our access points connected to them. We've got clients which are connecting to the access points. And in addition to this established model that we've previously used, we've now actually added wireless LAN controllers at the distribution layer of our traditional network. So now we've actually got our access points connecting into the layer 2 edge switches, but they're actually forming tunnels back to the wireless LAN controller, so that the wireless LAN controller can perform all of the management and control functions which are required. We also took a look at wireless LAN controller history, just to give us a little bit of context as to how we've arrived at where we are today. And we talked about the fact that back in the early days of wireless LAN networking, wireless LANs consisted of just 1 or 2 APs. It was fairly niche technology, and it was just provided for a small number of users doing some fairly specialized things. And then as the demand for wireless grew, as more and more people needed wireless LAN access, the number of access points required to meet the requirements of these users increased, and we got larger and larger networks, and it became more and more difficult to manage and coordinate these larger wireless LAN networks as they grew in size and complexity. And this is where the requirement for a centralized management and control point, i.e. a wireless LAN controller, actually grew from. As wireless LAN networks grew from a handful of wireless access points into wireless LANs consisting of tens, hundreds and even thousands of wireless access points, having a centralized administration point, i.e. the wireless LAN controller, meant that just with a few clicks it was possible to deploy consistent configurations and control masses of wireless access points to ensure they operated in an optimum fashion. And in addition to the development of wireless LAN controllers, we also needed some changes on the access point side of things. Rather than having a lot of standalone wireless access points with each one running its own individual configuration and its own individual operating code, we actually had a new breed of wireless access points that were developed to operate with wireless LAN controllers. These are known as lightweight access points. These had far less intelligence than previous standalone access points. All they had was some basic code to get them booted onto the network, which would allow them to talk to a controller via some sort of tunnel, which could then download their operating code and their configuration to get them onto the network. So this was another sort of major departure which came along with the development of wireless LAN controllers. In the early days of wireless LAN controllers, most were 19-inch hardware appliances that you'd usually expect to find in your data center or equipment room, and these are usually deployed towards the core of the network. But as the variety of environments that wireless LANs were required in grew, we saw things like smaller form factor wireless LAN controllers emerging, still hardware based, but these would be used in things like branch applications, and also with the rise of virtualized services, we saw wireless LAN controllers becoming available as VMs, which could obviously be deployed into existing VMware type environments or even hosted in the cloud. And as time's moved on, the capabilities of wireless access points have increased significantly, and we can now have some access points which can function as both an access point and as a small-scale wireless LAN controller. And finally, in episode 19, we introduced the concepts of the control plane, management plane, and data plane. These are conceptual planes of operation within wireless LAN network. You can find them in all wireless and wired networks. And this identifies different types of functionality within a network that we need to be able to understand and identify so that we understand exactly how our wireless LAN network is operating end to end. We talked about the control plane, which we can summarize as being the decision-making, coordinating, signaling plane of operation within the network. We talked about the management plane, which is more about the administration and monitoring of devices within the network. And we talked about the data plane, and this is the actual path over which user data, frames and packets flow. So this is typically going to be things like the logical and physical connectivity over which our user traffic flows across the network. And we'll be diving into each of these planes in a lot more depth in this particular episode so we can understand exactly what they bring to our wireless LAN infrastructure. Okay, so we've now completed our review of episode 19. We're going to dive into some new material, and if you're following along with the slides, we're actually on slide number 16. We're going to take a little bit more of a deep dive into the management plane. Okay, so we're talking about management of our wireless LAN infrastructure. The wireless LAN infrastructure itself consists of wireless LAN controllers and wireless access points in the main, and they're overlaid on some sort of wired infrastructure. And it's mainly AP management that we're concerned about. We're concerned that it's actually going to be consistently configured with the same SSIDs everywhere, using the same sort of security protocols, can have the same sort of VLAN settings, and just ensure that we've got a consistent policy of configuration across our entire estate. And there are actually two methods that we can use to perform this AP management. We can have either a dedicated centralized network management systems, an NMS system, or we can actually use the functionality of the wireless LAN controller itself to perform these configuration settings. And this may be a little bit confusing. We'll sort of break it down a little bit more later on. But if we're using a centralized dedicated network management system, what we find is that the network management system actually uses SNMP type protocols to perform the configuration changes and to gather things like event and performance data. And the network management platform itself could be an on-premise hardware appliance or VM, or it could be some sort of cloud management system. However, as I previously said, we've also got the wireless LAN controller itself, where we can perform many of the management configuration changes that we want directly from the wireless LAN controller itself. Very often you have a web GUI that you can log into and make whatever changes are required. Obviously, the wireless LAN controller isn't just used for network management. It's obviously got the control functions. It can act as a data path for user traffic. So it's a multi-function item, and it's probably not best served for wireless LAN management for larger estates. What you tend to find is that on fairly small networks where there's maybe one or two wireless LAN controllers, people tend to use the wireless LAN controller to do quite a large degree of the management of the wireless network. But once you get up to larger site, multi-wireless LAN controller deployments, especially if they're geographically dispersed, then it makes far more sense to have a dedicated network management system sitting above the wireless LAN controllers from a sort of topology point of view, so that it has a view of all wireless LAN controllers and hence all wireless access points, so that it can manage the entire estate from one centralized point. So, you will see a mix and match of these approaches. A dedicated network management system in larger installations, and then in probably lower end, smaller installations, there'll be a tendency to use the wireless LAN controller itself to do a fairly limited set of management functions. Wireless LAN controllers, the management function of them is fairly limited. You won't get things like long-term reporting, event management, things like this. And this is the sort of advantages that you have from having a dedicated management system. But the point is here, we're talking about the management plane, and it's just to demonstrate that the management plane resides in two places. It resides in your network management system, and it resides in the wireless LAN controller itself. If you're following along with the slide deck, if you could take a look at slide number 17, I've actually provided a diagram which tries to demonstrate the relationship from a management perspective between a management platform, wireless LAN controller, and the wireless access points on the network. I'll just briefly describe the diagram in case you're not actually in front of it at the moment. We've got a network management platform on the left-hand side, and traffic from the management platform flows over the LAN switch infrastructure to the wireless LAN controllers around the network at various points. And then we've got the connectivity across the wireless network again from the wireless LAN controllers out to the access points. And of course, the access points will be forming some sort of tunnel back to the wireless LAN controller. So typically, we'll have the management platform, which will be talking using protocols like SNMP or maybe some sort of XML over HTTPS to the wireless LAN controllers. So we'll be able to make configuration changes on the management platform. This will get pushed through via SNMP or HTTPS to the wireless LAN controller. And then we find that the wireless LAN controllers actually act as a proxy for the management traffic which goes out to the access points. So the wireless LAN controller receives typically an SNMP set command. It'll actually translate this into suitable data to be passed over the tunnel between the wireless LAN controller itself and the AP, and it'll get pushed through that tunnel to the AP to make the configuration change which is required. So we've got this proxying action of the wireless LAN controllers, which is quite important to understand when we're actually making changes from the management platform to make changes on a wireless access point. You need to understand it's not actually talking directly to the access point, it's actually talking via the wireless LAN controller, which is acting as a proxy for the management traffic. Just as a caveat, I just want to add that this technique is used by a large majority of controller-based systems, this concept of using the controller as a proxy for management traffic. But it's worth bearing in mind there may be some systems out there where perhaps this doesn't apply. But as a general principle, many times management traffic is received by the controller, pushes the management data over the tunnel that's been formed between the AP and the controller, and affects the changes on the AP itself. It's worth also bearing in mind that the implication of this is that your overall management platform doesn't need direct IP connectivity to your access points, as long as the management platform can talk to the wireless LAN controller, which is going to act on its behalf in terms of talking to the APs, then you're good to go in terms of being able to make changes from the management platform to your wireless access points. So in addition to the management function, which we've talked about there in some depth, we also need a control function across our wireless LAN infrastructure. And this is the control plane that we've previously discussed. We need a control function to provide us dynamic services and to change settings dynamically across the network. For instance, we need to maintain client connections as clients move around the network. We maybe need to adjust AP channel settings for changing conditions, maybe need to change AP transmit power settings to adapt to conditions, and moving encryption keys around to facilitate roaming as clients move. And this control functionality, as we've said, is known as the control plane of our wireless network. And more often than not, it's actually provided within our wireless LAN controller, as we would expect. The wireless LAN controller is a good place to make control decisions because it's got a centralized global view of the network. It can see all of the wireless access points, all of the clients that are associated, and so it can make centralized decisions to enable us to coordinate the control activity. So for instance, it can do dynamic AP channel planning. It can see all the neighbor reports from all of the access points across the infrastructure, and based on the channels it can see that are being used by the network and by neighbouring networks, it can do things like making channel planning decisions to adjust channels as required for the conditions. The centralized single wireless LAN controller option isn't the only option. If you're looking at a number of vendors, across many enterprise vendors, you will find there's a wireless LAN controller option as their primary offering, certainly for larger enterprise offerings. But we've also got the Aerohive solution, which doesn't actually use wireless LAN controllers at all. You may come across this. It actually uses a distributed control system where it actually uses a number of network protocols to distribute the control plane amongst all of the access points which comprise the wireless LAN network. And we'll come back to that in a moment. But generally, many vendors use wireless LAN controller or multiple wireless LAN controllers across their wireless LAN infrastructure, which will all exchange data with each other to facilitate control decisions across a whole cluster of wireless LAN controllers, typically if we've got a larger campus environment. And typically beyond anything other than the most basic requirements of a handful of wireless access points, we really do need this centralized control function, which is provided typically by a wireless LAN controller. Just coming back to Aerohive for a moment, as I say, they use a distributed, coordinated control plane, which is distributed amongst all of the APs. So you will have access points which are distributed as you normally would have across an enterprise wireless LAN environment, but many of the APs actually talk to each other using control traffic. It's using a series of protocols, which are analogous to routing protocols, if you imagine the way that routers actually talk to each other to exchange routing update information. The access points actually exchange control information so that they can make collective decisions which are distributed throughout the AP infrastructure, and make the same sorts of decisions that you would expect from a wireless LAN controller environment. Obviously, the advantage of the solution from Aerohive is that it doesn't actually require wireless LAN controllers, which can be a good thing when you start thinking about things like component failure and things like that. But we'll come back to that at a later date. In addition to the management plane and the control plane, which we've spoken about, we also, of course, need the data plane. And this is the physical or logical path that's actually taken by the user traffic. So if you imagine a wireless client that's actually associated to an access point, accesses services across the wireless LAN and the wired infrastructure, the data plane is the actual path that it will take across that network to access the services that it needs. We've got a number of options in terms of the implementation of the data plane. We can actually use a data plane which is locally switched at the access point itself so that it directly travels travels over the wired infrastructure, or we can actually get our data to be centrally switched so that it travels all the way back to the wireless LAN controller and can be dealt with at the centralized point. But we'll look at these options in a lot more detail in a few slides' time. We've mentioned a few times the various form factors in which wireless LAN controllers are available. I'm just going to spend a few moments actually going through those and talk about each one in a little bit more depth now. If you're following along with the slide deck, I've got slide number 21, which has got some pictures there where you can see various form factors that you may meet out in the real world. On the left-hand side of the diagram, we've actually got dedicated wireless LAN controller hardware. Next to that, we've got some symbols for virtualized or cloud controllers. So this is typically a controller which is maybe implemented as a VM in something like a VMware environment, or maybe we've got the controller itself which is actually provided as a service in the cloud. And again, this could be a VM instance or it could be hardware. It's usually hidden away from end users' site. We've also then got dual role APs, and these are APs which can act either as an access point or as a mini controller. And then finally, on the far right hand side, we've actually got a unified access or an embedded controller implementation, and these are certainly being offered by some manufacturers where the wireless LAN controller functionality itself is actually being built into existing switching hardware. So we'll have a look at those each in a little bit more detail now. So considering the hardware implementation of a wireless LAN controller, we tend to have the traditional 19-inch hardware platforms, which are usually 1 or 2U in height, which goes into a standard data center type rack. And these tend to be used in medium, large enterprise environments, certainly in areas such as stadiums and other high-end deployments where we've got a high number of clients, high number of access points, which all needs to be managed and controlled, but also in terms of hardware implementations of wireless LAN controllers, we've got smaller scale form factors which are suited to smaller branch and SME type environments. They're still dedicated wireless LAN controller hardware platforms, but they've got much smaller levels of resources to handle lower levels of clients and smaller numbers of wireless access points. There may not even be a typical 19-inch rack-mounted piece of equipment. They could be a much smaller chassis to maybe sit on a tabletop or similar in a smaller environment. Beyond the dedicated hardware platforms, we've got cloud-based implementations of wireless LAN controllers. And as I said previously, these could actually be a physical hardware platform which is implemented in the cloud, or more likely it'll be some sort of VM instance which has been implemented in the cloud. And this is hidden away from the end customer. It's provided as a wireless LAN controller service. It tends to vary in scale. You tend to get what you pay for. If you want larger scale deployments, then you're going to have to pay more for the resources for that. You can get mid-size type enterprise deployments and down to sort of SME type levels when you're using cloud-based controllers. There are limits on what can be achieved with cloud-based controllers because obviously there's a dependency on the internet pipe that you've got to connect you into your cloud-based supplier. It's also worth bearing in mind when talking about cloud-based services, are you actually buying a cloud-based controller, a cloud-based wireless LAN controller solution, or are you actually just buying a cloud-based management solution? This is where the understanding of our control plane and management claim becomes key. You need to understand, are you actually buying a management function or are you buying a management and control function? There are many cloud-based offerings which may be purely management only. You're not actually going to get the control function that perhaps you're expecting. Looking again at on-premise implementations of wireless LAN controllers as opposed to cloud-based, we've got instances of virtualized controllers which we can run in a VM environment. So if we've got something like VMware or Hyper-V, we can actually get an image of the controller itself from a vendor. We can spin that up as a VM in our VMware environment, and then we can actually use that in the same way as we would a VM hardware platform. There are a few limitations with regard to running a wireless LAN controller as a VM. It may be difficult to actually get the resources which are required to run a wireless LAN controller. You certainly need things like dedicated Ethernet NICs within your VMware environment to run a controller. And typically you won't find the same levels of performance that you would get from a dedicated hardware platform. But they are nonetheless very useful, probably for more mid-sized, smaller-sized environments where you'd like to spin up a wireless LAN controller as a VM. We've also got dual function APs, which we've mentioned a few times already, and this is something that's fairly recently started to be offered by a number of wireless LAN vendors. Some models of wireless access points have evolved to such a high level now in terms of resources that they can actually act as either a wireless access point, or they can actually be switched into a mode to act as a mini wireless LAN controller. So typically one of the access points will be designated as the mini wireless LAN controller, and other APs in the area will associate with it, and then it will act providing the management and control functions you'd expect from a dedicated wireless LAN controller hardware platform. Typically at the moment it seems to scale up to around about 10 to 25 APs that can be associated with a mini wireless LAN controller access point. It will vary from manufacturer to manufacturer, and no doubt this will scale up over time, but very, very useful for smaller branch type environments, SME type environments. In terms of brand names, you may have heard of things like Aruba Instant or Cisco Mobility Express, which implement this type of functionality. It's also worth mentioning the wireless LAN manufacturer Xirus, who you may or may not have heard of. They're not exactly dual function APs, but they actually provide a wireless array, which is effectively a wireless LAN controller board which has a number of radio modules plugged into it. So it is effectively a wireless LAN controller which is acting with AP type functionality at the same time. But as I say, there can be multiple radios installed there, so we're not limited to just 2 radios of a traditional AP. Depending on the model that's bought, you can have 4, 8 or 16 radios installed into an array. And finally, we've got the Unified Access wireless LAN controller form factor. This is a wireless LAN controller functionality that's actually built into an existing piece of network equipment, and this would typically be a network switch. And the wireless LAN controller functionality is actually included as part of the native functionality of the switch. It's part of the OS that the switch runs. We're not talking about slot-in modules here, which are actually added to the switch or any other piece of equipment. It is actually a core integral part of the OS of the device itself, and it provides a useful way of combining both wired and wireless access at the edge of the network. And finally, while discussing wireless LAN controller form factors, we also have to remember that the option of no wireless LAN controller is also an option. If you're talking about the AeroHive solution that we've talked about previously, obviously the control function is distributed amongst APs. There is no actual physical wireless LAN controller at all, so we don't actually need a wireless LAN controller for that particular solution. Okay, well that's probably enough for this particular episode. We've covered quite a bit of information looking at wireless LAN controllers here, and we'll continue our discussion certainly in the next episode of the podcast, talking about wireless control and management in this module, which is module number 6. So I'm just going to briefly finish up by recapping what we've actually covered in this particular episode. We started off by taking a look at the management plane in a little bit more depth. We talked about the way that we can have a dedicated management platform together with the wireless LAN controller to form our management plane. We can use the wireless LAN controller itself to make configuration updates and changes, and similarly we can use the dedicated network management system to make similar sorts of changes. We also had a look at the relationship of the management platform to wireless LAN controllers and the way that configuration information is typically passed through to wireless access points. We talked about the fact that a management platform will send configuration data to a wireless LAN controller, and the controller will typically act as a proxy for data to and from the wireless access point itself. We also then had a look at the control plane and the need for a centralized control function to provide dynamic services and to dynamically change settings across the infrastructure for us. And we talked about the fact that a wireless LAN controller provides a ideal location to provide this control function because it has a centralized global view of the network, so it can make centralized decisions and coordinate all of the control activity across the network. We also mentioned as well that wireless LAN controller is not the only option for implementing control on a network. We've got the Aerohive solution, which uses a cooperative control solution, which doesn't actually use wireless LAN controllers at all. But the vast majority of Wi-Fi vendors do actually provide a controller to implement the control plane. We spoke briefly about the data plane, and we talked about the fact that we can have locally switched or centrally switched data flowing across the data plane. We also took a look at the various form factors of wireless LAN controller which are available today. We looked at dedicated hardware platforms. We talked about virtualized and cloud controllers. We looked at dual role APs, and we also looked at the role of unified access wireless LAN controllers. So that pretty much wraps it up for this particular edition of the podcast. Hope you've enjoyed it. Hope it's had some useful information contained within it for you. And as I say, in the next episode, we will actually be continuing our discussions of wireless control and management in respect to wireless LAN networks. Don't forget you can get along to my website, which is wififorbeginners.com, where you can find copies of all of the audio from the series. You can find copies of the slides, you find quizzes, and you can certainly sign up to my newsletter, which I put out periodically to update you with various offers and things that are going on with the podcast. It's a good way of keeping up to date. So strongly encourage you to get along to wififorbeginners.com and sign up for that if you can. Okay, well, I hope this has been a useful episode, and I look forward to joining you again very soon on the next edition of the Wi-Fi for Beginners podcast.